We're looking at how we can use plants on Earth to try and help enable spaceflight and how humans can populate both the Moon and Mars. I'm Nicholas Brereton, so I'm an Assistant Professor and Ad Astra Fellow in the School of Biology and Environmental Science at UCD.
2, 1.
Humans are going back to the Moon,
We have liftoff.
where we can test the technologies needed for future missions to Mars. We aim to have a permanent colony on the Moon by the early 2030s. One of the challenges is the ability to grow food and to try and take some of the environment that we have on Earth with us to space. Plants grown in lunar soil don't survive at the moment. That lunar regolith is challenging and toxic. It also doesn't have any microbes or organic matter. Much like humans, plants have the same microbiome. They need that microbiome to be able to process nutrients, as well as fight disease. And so we're trying to identify particular microbes which exist in plant root systems and enable those plants to overcome really extreme stress. So at UCD, we're using lunar simulant soils. These are built from Armstrong's samples that were taken during the Apollo missions.
Oh, it's beautiful, Mike, it really is.
Put in the back of the lunar lander, and has provided a unique insight into the composition of the lunar surface. So what we're doing is adding in microbes and growing plants which are resilient plants from Earth, and harnessing the diversity of plants on Earth and the microbes in those environments. And the diversity we have on Earth can overcome most challenges that we do face. And so those metals that are present, those low organic situations that we have on the Moon and Mars, we replicate that with some of the industrial processes we have on Earth. The work part is an open science community, so it's run by NASA. This is the analysis working group for plants and analysis working group for microbes. These are researchers from around the world that give different perspectives. We're currently analysing or repeating some of the challenges that we see in space, working out how to overcome those challenges to grow crops, to help complement food production, but also overcome some of the challenges of soils which might damage astronaut health. And we have plants that can overcome that. The lessons learned is how to improve the sustainability of agriculture. We're also bringing some of the solutions from space to deal with contaminants potentially in Irish water and around Europe that are polluted from actions such as fireworks or conflict regions that produce pollutants. We have bacteria inside roots that can overcome those challenges. The solutions we're finding directly provide new perspectives on how to deal with pollution on Earth.